Okay, so we're going to talk about the Chapter 6 test. And this will be a little study guide for that test. So, and some of these questions will require a lot of explanation, some won't. And so I'll go through and add some work for the ones that do, and for the others we'll just analyze them. So what is the augmented matrix for the given system? Well, first of all, augmented matrices include the solution matrix attached. So A and B are excluded as a consequence of that. -5, +2, -21, +3, -4, +21. So only C matches. You notice D has a 2 where a 3 should be. So that's why B is incorrect. C is the answer we're looking for. C is in Charlie. Which matrix is not in row echelon form? So if we look at this, 1's on the main diagonal. So everyone has 1's on the main diagonal except for F. So we needn't even concern ourselves with the other values. 1's on the main diagonal is the first and primary rule for row echelon form. The other rule is 0's below those 1's. So F fails the first criteria, and so it's F as in Foxtrot. So for number 3, we're tasked with solving that system, and I don't concern myself with prescribed methods here. Just use whatever method you would like. So I'm going to use the Rref method, meaning I needed to create a 3x4 augmented coefficient matrix, and it should be 2, -1, 3, -4, -1, 2, -1, 0, 1, 2, 1, and -4 again. So let's just double check ourselves here. If it's a test question, it's well worth your time to double check the values. So -1, 2, 2, okay? And then the first one is 2, -1, 1. That all looks good. So if I hit quit, and then Rrefa, I see that it is -1, -1, -1. D is in delta is the answer. And that's by the calculator and Rref method. For number 4, the table shows several packages of assorted shapes available at a craft store. What is the price per shape? So we know the first person purchased 20 hearts, 20 diamonds, and they paid $3. Second person, 40 hearts, 20 stars, 10 diamonds, $6. And the last person, 50 hearts, 50 stars, 50 diamonds, and they paid $15. So in order to find these, we need to create an augmented coefficient matrix once again, and Rref. So let's edit that A again. And this time we want 20, 0, 20, and 3. What in the world? So we'd say 3, not 30. There we go. That'll start with 20, 0, 20, and then 3, 40, 20, 10, and 6, and then 50, 50, 50, and 15. And if we already have a Rrefa inputted from the last entry, I can hit second entry to recall that last entry. And I see that it's a nickel, 15 cents, and then a dime. So 5, 15, 10. It's H is in hotel. It's the one that matches our answer. Okay, so finding the determinant of a 3x3 matrix is something we'll do by calculator. You can do it by hand. It's possible, but it's a lot of work, and calculator handles it so seamlessly. It's not a good choice for a test. All right, so -2, 4, 0, 3, -4, -1, and then 2, -1, and 0. Double check your inputs. And then matrix math, the very first option is DET. And then we want to call the first matrix A. We get -6. So the answer B is in Bravo for this one. Now for 6, if find EF, if E is this and F is that, we could do it by hand, but there's some decimals in there. So calculator is a better choice, just removes the potential for error. So I'm going to edit A, make it a 2 by 2, like the A from our problem. -3, 2, -1, 0.5. And then we'll redefine B also as a 2 by 2. And it is -0.1, 3, 0, and -2. So now I'm going to do matrix A times matrix B. So we get 0.3, -13, 0.1, -4, positive 0.3, -13, 0. I think it's G is in golf. Just looking for what disqualifies the other. Yeah, so here, this is negative, here this is negative, and here, both those two are negative. Yeah, so G is in golf. Find the inverse, if it exists. So, we'll define A once again to be our matrix in question. And it is -5, 4, 1, -1. I believe the determinant's going to exist because I don't think that will have a, or the inverse is going to exist because I don't think it will be a 0 determinant. So A and then the inverse button, it gives us -1, -4, -1, -5. Looks like A. Yes. A is in alpha. All right, and then on to page 2 here. So, given that A is this and AC is that, find C. So this one will require a bit more work. Take it to a separate page. So this is an often missed question on this test, very often missed. I think a lot of people see that it's going to take more than a couple minutes. They throw their hands up and check one of these randomly and go on. Don't do that. It's very solvable. So A, AC. Do you see how if I say A inverse times so if I multiply both sides by A inverse here, so that cancels and I get C equals A inverse times that. So I need to program in my calculator A and C. So let's edit A and make it -4, -1, 3, and 5. And so this is actually AC, so I'll tell you what, let's program that in as B to avoid confusion. If I make it C, that would be weird. So we'll say A times C will be B in our calculator. And sometimes you can write that here just to keep yourself from getting confused if you use a different name in your calculator. So it's also a 2 by 2, and it's 24, -4, -18, and -14. And so if I click to the home screen and I do matrix A, inverse button, times matrix B, I get C. So -6, +2, 0, 4. The answer is J is in Juliet. Okay, so solve the following systems of equations using an inverse matrix. So you can solve it however you like. You can do RREF, or if you want to practice those different techniques, you can do that. I'm going to use RREF just because it'll be a little faster. I'll take up any more of your time than I have to. So I'm going to make this a 3 by 4. And I'm going to take the first row from equation 1. -3, 2, -1, 19. And then here, 1, -4, 2, -18. And the last one from the last equation, so that's -1, 0. That 0 part's kind of tricky. 3, -5. And then RREF 8, and it's -4, 2, 3. It's -4, 2, -3, I should say. C is in Charlie. All right, use Kramer's rule to solve the system of equations. Once again, you can, but I'm going to use REF just to save time. So let's edit A again. This time it needs to be a 2 by 3. And it should be 6, -2, 28. And it should be -1, 1, -8. And then RREF 8, 3, and -5. F as in Foxtrot. Okay, pets. Willie's Pet Store sells puppies and kittens. Last week there were 5 puppies and 4 kittens sold, earning $3.88. This week there were 8 puppies and 7 kittens sold, earning $6.43. What was the selling price of 1 kitten? So we want to solve for the kittens. We'll just let the puppies be X, and Y equals the kitty, which gives us the following equations. 5x plus 4y equals 388. That is really illegible. Let me go down a size in pen here. And then 8x plus 7y equals 643. So that's our system we need to solve. And we want to know the value of y. So we only care about y. We'll go ahead and solve the system. You could use Kramer's rule here and make it save yourself a second. But I don't even know if it will save time on this problem. 5, 4, 3, 8, 8. 8, 7, 6, 4, 3. I get 48 and 37. We only care about 37. D is in delta. Oops. I'll write the answer down. I still did it. D is in delta. There we go. Okay, so 12 is the challenging one. We want to find the partial fraction decomposition of the following. So let's take that to another page. And that was from 6.4. Partial fraction decomposition of the following. So the first thing we need to do is determine the type of the situation here. The denominator is higher degree, so we don't have to worry about long division. The denominator, is it factorable? So let's see. 3x squared plus 11x minus 4. And I want to factor this if possible. So if it's possible, I need to regroup the center term in such a way where the sum is 11 and the product is -12. So yeah, I think that'll be +12 and -1. If that meets my criteria. Yes, I believe it does. Okay, so we're going to regroup that middle term, 3x squared plus 12x plus negative x minus 4. And so factor out the GCF from both parts here. So that's 3x times x plus 4. And then if I factor out a negative 1 here, this, and so we have 3x minus 1 times x plus 4. So it is factorable, and they are distinct linear factors. So it's like the very first example I did in 6.4. And I can rewrite that original as equal to sum A over 3x minus 1 plus sum B over x plus 4. So let's get matching denominators here. 9x minus 16 over 3x squared plus 11x minus 4 equals A times x plus 4 over 3x minus 1 times x plus 4 plus B times 3x minus 1 over x plus 4 times 3x minus 1. And as I said when I went through the lesson, the excluded values aren't very important here, but most of the time they are, so it's good to be conscious of them. We know that x could never equal negative 4 or 1 positive 1/3, because those would be the zeros of those. Now we can set the numerators equal. Like so. And now we just solve for a and b here. So 9x minus 16 equals ax plus 4a plus 3bx minus b. So combining our like terms here, that's a plus 3b times x plus 4a minus b. And I know that the x term, the coefficients have to match, and so a plus 3b has to equal 9. And for the y term, I'm sorry, for the constant term, 4a minus b has to be negative 16, so which allows us to develop a system. A plus 3b equals 9, and 4a minus b equals 16. So we create a matrix here. 1, 3, 9, 4, negative 1, 16. And so we're going to get A, B equals whatever the rightmost column of that matrix is after we RREF it. So I want this to be a 1, 3, 9, and then a 4, a negative 1, and then a 16. So that's, I've got some funky fractions there. That doesn't make a lot of sense. Double check myself. Be a boo-boo somewhere. All right, so 3x minus 1 x plus 4. I believe that factorization is valid. What else is in there? Plus 4. Bx minus b. Okay, now, negative 16. Okay, that was my big one. Let's fix it. That's probably something good for you to see because you'll run into something similar, I'm sure. That should be negative 16. Now let's try it. So negative 3 and positive 4. That makes a lot more sense. So we want negative 3 over 3x plus 1. And now notice it might be in a different order in the answer, so it's important to come up here and really think about what matches. So we need the term over 3x minus 1 to have negative 3. So here I've got that term that matches this term. I think that's maybe the only one that agrees. Yeah, okay, so we can exclude all other answers from this point, and F, as in Foxtrot, is the answer to 12. So all that work will be attached when I post it. All right, so 13 says, find the minimum value of the objective function subject to the following constraints. So that's another one where we'll need a separate page to work on. And there's just a few left, so. Okay, we'll need a graph as well. So x greater than or equal to 0, y greater than equal to 0. This just confines us to Q1. So we can use the existing x and y axes to serve as our boundaries there. And then I've got x plus y is less than or equal to 6, and I'm going to plot the boundary, which will be y equals negative x plus 6. So if I go up to 6, 1, 2, 3, 4, 5, 6. And then down 1 over 1, down 1 over 1, and so on. So I get out here to 6, 0. So this is my boundary there. And then it says y is less than or equal to 3. So that's just a horizontal line here. And so my solution area is going to be like this. And we need to find all those vertices, which are at 0, 0. We're going to plug these into our objective function. And then 0, 3. And then 1, 2, 3, 4. That looks like 4. It wouldn't be. It'd be 3, 3. I showed my circle in a weird spot. So it's 3, 3. That would be a point on both of those. And then 6, 0. So if we plug that into 2x plus 3y, that's 0. 2 times 0 plus 3 times 3 is 9. And then 2 times 3, 6, plus 3 times 3, 9, it's 15. And then 6 times 2 is 12, plus 0. All right, so we want to find the maximum value. It's 15. C is in Charlie. Same kind of problem. So these two together just confine us to Q1 again. I'm going to write over my objective function. So these two together just confine us to Q1. So we'll use the existing x and y axes again as our boundaries there. X less than or equal to 3, that's going to be a vertical line. And then y less than or equal to 2, horizontal line here. And anything outside of Q1 is not really relevant in this case. and x plus y greater than or equal to 1. So that means y equals negative x plus y. Anybody? You looking for Patrick Roberts?
Yeah,
He'd be in Jason Clevenger's room.
Clevenger's. Okay, I just need Mr. Henry needs a square.
Yeah, help yourself. He's got, I think they're on the wall on the right as soon as you go in.
Okay, thank you.
You're welcome, buddy. Speed square is a handy thing, brother. Okay, so negative x plus 1. So we come up here to 1. Just double checking myself. Yeah. Kind of supersedes one of the other ones. That's okay. And then it's got a slope of -1, so kind of like that. And I'm pretty sure the origin would fail here. Let me just double check that. Yes. So it's this area. All right, yeah, that makes sense. Let me get my little highlight. So here's our solution area, and we need to find the vertices. So they are this one, this one, this one, this one, and this one. So that one is 0, 1. That one is 0, 2. That one is 1, 2, 3, 3, 2. That one is 1, 0. And that one is 3, 0. And in this case, we want the minimum value. So read that carefully. That would trip you up if you weren't watching for it. So we want negative x plus 2y. It's going to be 2 here. It's going to be 4 here. Negative 3 plus 4. Sorry. So you said, yeah, it's a speed score. Yeah,
I'm thinking.
You thinking that little half triangle thing?
Half triangle, yeah.
Yeah. Well, that's what it looks like for brick masons.
Good.
You too, brother. All right. So the 1, 0 here is going to be -1. 3, 0 here is going to be -3, and that is our minimum value, -3. And it occurs at 3, 0. G is in golf. That's our answer there. So we'll use a graph again. We're going to develop our constraints from the word problem here. So I'm going to let x equal bottles of water. So x is water, y is juice. So he cannot buy more than 8 bottles of water. So x is less than or equal to 8. Or 10 bottles of juice. Y is less than or equal to 10. If a bottle of water costs 2, so that means 2x plus 3.5y is our objective function. So that's the one we want to maximize, because we want to know the most money he can spend. There's our objective function to maximize in this case. And we're also confined to Q1 because it's understood that you can't, go into the negatives. You can't sell them bottles of water or juice. So we'll confine ourselves once again to Q1. And then we'll say x is less than 8, which is vertical line there. And y is less than 10, so that's just a graph here. So here is our feasible read, but we'll see where it intersects here. So you got this line still. You got this line still. But here we've got 14 as our y-intercept, and then it's going to slope of -1. So if I come out here to 4, it's going to have this point, and then it's going to go like so. All right, so that adds that line and makes our feasible region this area. So these are our vertices of our feasible region. F of 0, 0, F of 0, 10, F of 4, 10, F of 8, 6, and F of 8, 0. So we multiply the x by 2 and y by 3.5. So it's going to be 0, it's going to be 35. It's going to be 35 plus 8, which is 43. This is going to be 16 plus 6 times 3.5 is 18 plus 3, 21. So 21 plus 16 is 21 plus 16. Double check this one. 27. And then the last one, 8 times 2 is just 16. So the highest value here occurs at 43. 43 is our max. B is in Bravo. All right, good luck on the test, and I hope you guys do well. Don't forget to get it done on time. Sunday, I did that on purpose because I didn't want you to have to wait through all fall break and worry about it. Just get it over with and enjoy your break. See you next time.